Lesson number 6 about solar energy. During this lesson, I'm going to explain determining PV array maximum system voltage. So, for example, if we have a solar panel or a solar string, solar string, it consists of a number of solar panels. Then the output voltage of this string, the whole string, the output voltage or DC voltage, the DC voltage, V DC will equal a value, any value. So let's say, for example, this system produce a 300 volt. In this lesson, I'm going to explain about this voltage and what is the meaning of the output DC volt. So all components, or before this point, the maximum DC voltage commonly is a safety relevant limit for sizing a PV system. In this example, maybe I say I want the system to produce 3000 volts, of course DC volts. So here I have a problem concerned with the safety. So for safety purposes, the voltage should not exceed 600 volts, in the regions when there is a human at our houses, or maybe up to 1000 volt in some commercial application, and maybe 1500 volts for special purposes. So all components, modules, inverters, cables, connectors, and fuses have a certain maximum voltage they can handle safely. So for example, for this system, the modules, inverter, cables can handle up to 600 volts. So in this case, there is no problem. The output voltage is 300 volt. Of course, this is the V open circuit, the maximum voltage. But if we have, instead of, if the output voltage, let's say VDC out equal, for example, 3000 volts. So here we have a problem. This voltage is more than 600. So here we have two problems. The first problem is relevant to safety, and the second problem is concerned with the components. So we have a problem with the inverters or cables. The inverters or cable maybe cannot handle this high voltage, so we don't have to use a large voltage. So according to our system, if we use a 600 volt system, so the maximum voltage here should not exceed 600 volt. So if this voltage get exceeded, damage or even worse harm can result. New technologies established and a new standard to build PV systems with voltage up to 1000, so we can use 1000 for special purposes in big PV power plants with central inverter topology. Even up to 1500 are used. So the question is, what is the advantage of using high voltage PV system? So we have four advantages. The first one, lower losses, reducing the string number. So string mean, for example, instead of use 3 solar panels on series, we can use just 2. So reduce the string number. we can see here, this is the model, and this is the smallest part, the cell. Okay, so a collection of cells produce a model, and if we connect the models on series, then we have a string. So this is called a string. So again, reducing the string number, and of course, because we have or reduce the string number, so this led to reducing cables, connectors, fuses, and so on. And of course, we can see the space. So this string need a smaller space than this string, so lower space requirements and high reliability. But there is a problem. Before the problem, the advantage of higher voltage is lower cost. So when we have high voltage, we have lower cost. But the problem is voltages are limited by practical and safety concern. So here is the challenge, is how to size a PV system with the highest possible and safe DC voltage. So if the allowable DC voltage is 600, so how to design our PV system so that we produce a maximum voltage which is 600 or less. So here we have a practical example. So the standard panel size that used for rooftop uh, appear to be the nominal 300 watt unit, giving a nominal voltage. Okay, so the nominal voltage during the operation is 36 or 48 volt. So this is the nominal voltage with a maximum open circuit. But when the solar panels are open or there is no load here, so the voltage is between 42 or 50 volt. Okay, so the voltage between 42 or 50 volt. In the United States, the maximum voltage should be no exceed 600 volt DC, because they design their devices to handle maximum voltage of 600 volt. In cold weather and sunny day, so when the temperature is low, for example 3 degrees Celsius or lower, and sunny conditions, array voltage will increase. So as we can see from this curve, in this curve we can see this is the open voltage or the voltage of the open circuit. We have three temperatures: 25 Celsius, 45, and 65. So we can see here at 25 Celsius we have the maximum V open circuit or the voltage at the open circuit, and when the temperature increase from 25 to 45, so you can see the maximum voltage decrease. And finally, when we have 65 volts, we can see here we have the lowest open voltage, open DC voltage. So now we go back. So again, in cold sunny conditions, array voltage will increase. Okay, so when the temperature is low, the voltage will increase. The increment in the voltage should be taken into consideration when designing a PV solar system, so the voltage stays below the limit. So we should not exceed the limit. To do the correct calculation, you should know the minimum temperature of the location where you plan to install the system. For example, I want to install my system in the Hawk city. So we can find this curve from the internet. We can see we have two things in the curve: the day and the night. Of course, we depends just on the day, because here there is a sun, but in the night there is no sun. So we don't use the lower curve, just the upper curve. We can see from this curve that the lowest temperature is about here. In On January, it's about 12 Celsius. Okay, and the temperature start to increase. Here we have the maximum temperature, and then decrease to this value. It's about 13 Celsius. So the minimum temperature during the year, of course, this is for January, February, during the year at the day. So this is at the day, not at the night. At the day is about 12 Celsius. So we have to take this value into consideration. Another curve, we maybe see the curve like this. So you can see here also we have the day and night. So the upper one, this is for the day. So you can see this is the temperature on January. Okay, then here we have February and so on. So I think this is the lowest value, and the temperature is about 12 or 11 Celsius. Okay, so this is the lowest value. So you can see this is the curve of the temperature during the day. Okay, also we have, this is a low value, but this one is lower. The other curve, this one, is for the night. Okay, so you can see this is minus 10, about 10 Celsius, but we don't use this curve, okay, because this curve is for the night and there is no sunshine on the sky. PV model manufacturer provide a temperature coefficient. So we have a temperature coefficient of open circuit voltage. Okay, so this symbol TK V open circuit, this means temperature coefficient of open circuit voltage. It must be used in calculation. So how to calculate the maximum voltage? We are going to see in the next slide. So this coefficient tell us how much a model's voltage will increase per Celsius below the standard test condition STC of 25 Celsius. So the provided coefficient, it's for the standard condition at temperature 25. The temperature coefficient will be listed in volt per Celsius or millivolt per Celsius, or maybe a percentage per Celsius. So how to concern with this coefficient, we are going to see in the next slides. So here we have an example. If a model has a TK V open circuit of 0.12 volt per Celsius, this means that for each Celsius below 25 degrees Celsius, the model voltage will increase by 0.12 volts. So for example, let's say if the temperature, okay, or sorry, the DC V open circuit at the standard, for example, it's equal to 36.9 volt. Now let's take an example. If the temperature, let's say, if of course this value at the temperature 25 Celsius. So what will happen if the temperature increase by 1? So it equal 26 Celsius, or the temperature decrease by 1. So it's equal 24 Celsius. So if the temperature increase by 1, So this value will be 36.9. Because the temperature increase, so the voltage decrease. So we say minus because the voltage decrease. So decrease by, here we have the value. So we said that the value is 0.12. So minus 0.12. Okay, and it's equal a number. But if the temperature decrease by 1, so in this case, if the temperature decrease, so the voltage increase. So we say 36.9. In this case, plus 0.12. Okay, and we have the result. So in this case, the temperature increase. Okay, the temperature increased by 0.12 or 12, and when the temperature, we can see when the temperature increase, so the voltage or the DC voltage, of course this is V open circuit, so we can see decrease by 0.12. Another example, if we have a module with TKV open circuit given in percentage per Silesian. So how to solve this problem? We have also an example about it. So multiply this TKV open circuit by the module's open circuit voltage. So for example, a module with V open circuit equal 36.9 volt and TKV open circuit of, you can see here we have in percentage, so 0.36% degree Celsius will have a 0.133. So how to calculate this value? Because the value is, or the, we can see here the TKV open circuit, this is in percentage, so we multiply this value by V open circuit at 25 Silesian. So we can see multiply this value, so we have this value, this mean 0.36%. Okay, so it's equal 0.0036 multiplied by 36.9 volt, and the result equal about 0.133 volt. So once we have this calculation, we must determine the lowest expected ambient temperature. So now let's see in more detail. So for the 25 Silesian, we have, okay, degree Celsius, we have the V open circuit equal 36.9 volt, 0.9 volt. Now what will happen if the temperature increase by 1 or decrease by 1? So at 26 Celsius and 24 Celsius. As we said, here we have the temperature will change by 0.133 for each degree Celsius. So in this case, because the temperature increase, so we say V open circuit equal 36.9. This is for 25 volt, or sorry, 25 degrees Celsius. So when the temperature increase, the voltage decrease. So we say minus 0.133. So in the next case, when the temperature decrease, so we have V open circuit equal, so when temperature decrease, we can see we have 24, V open circuit increase, and in this case the temperature decreased by 1 degree Celsius. So the temperature or the final V open circuit will be 36.9 plus 0.133. Let's see this example. Let's assume our array uses a module with a voltage V open circuit equal to 36.9 volts and TK V open circuit equal 0.36% per degree Celsius, and it located in Albany, New York. The extreme minimum temperature for this location is listed as, so we have the lowest temperature at the day, which is equal minus 23 Celsius. So we should be careful from this value. So now we have to calculate the coefficient. Okay, this coefficient Tk, we have to calculate Tk V open circuit. So we have to calculate this coefficient. To calculate this coefficient, we multiply, we can see 0.0036, so this is value, by the V open circuit at 25 degree Celsius. So this is the standard value. So we have 0.133 volt. So this means voltage increase by 0.133 volt for each degree, okay, for each degree below 25 degree Celsius. Now we can see the lowest value is minus 23. So here we can say minus 23, the standard value is 25. But here we have the lowest value is minus 23. So what is the difference between 25 and minus 23? To calculate the difference, we say minus 23 minus 25. So we can see the difference between 25 and minus 23 is minus 48 degrees Celsius. Each degree produce 0.133 volt, and we have 48 degree Celsius, as we can see. So we multiply this difference, okay, the difference 48 degrees Celsius, so multiply the 48 by 0.133 volt, and we have 6.38 volt. So the V open circuit, this means at 25 degree Celsius we have V open circuit equal 36.9, and when the temperature is minus 23 Celsius, V open circuit equal, how to calculate V open circuit? From this formula. So we have 36.9 plus this value 6.38, and we have 43.28. Okay, so that means our maximum module V open circuit is now, so this is the maximum voltage that each solar panel can produce. So this solar panel, the maximum voltage V open is 40, this value is 43.28. So now if we design a system with 12 modules in series, so we have 12 modules in series. Okay, so we connect these 12 modules on series. So the output voltage will be, how to calculate the output voltage? To calculate the output voltage, we multiply 12 multiply by the maximum voltage. The maximum voltage is 43.28. So multiply by 43.28, and it's equal, we can see, 519.36 or 0.4. So this is the maximum voltage, and we can see this value is under or less than 600 volts. So there is no problem according to the United States standard. But if we use 14 instead of 12, we use 14 modules on series. So we multiply this value by 14, and we have 605 volt, or nearly at 606 volt. So we can see this value is more than 600 volt. So we cannot use 14 panels on series. Finally, this is a question or a homework. So suppose a maximum limited DC voltage for PV system is 600 V DC. Let's assume our array uses modules with, we can see here we have V open circuit 37 volt. Of course, this is at 25 degree Celsius, and TK, the coefficient of the open voltage circuit, is 0.34% per degree Celsius. How many modules should be connected in the string if we install the system in Duhok, Erbil, and Suleymania? So we have not find the lowest temperature from the internet. Okay, so you can use the internet to find the lowest temperature and attach figures or charts with your solution. Thank you for your listening.